Welcome everyone. Today I'm gonna introduce you with the topic structural design patterns for real-time systems. Let's start. So structural design patterns. For this video research contest, I have chosen patterns, proxy pattern and observer pattern. Proxy pattern's purpose is it is used for resource management. The proxy pattern can be applied in real-time systems to control access to resources and manage their availability efficiently. Observer pattern used this pattern allows multiple objects to be notified of changes in the state of another object. In real-time systems, the observer pattern can be used to synchronize and coordinate events effectively. Implementation and usage. Proxy pattern, first of all, is implemented by creating a surrogate or placeholder for another object to control access to it. In real-time systems, the proxy pattern is commonly used for resource management, access control, or providing a surrogate for another object. For example, in real-time monitoring system, the proxy pattern can be used to control access to a resource-intensive object, such as a sensor or a data source, to ensure efficient resource utilization. In real-time systems, the proxy pattern helps meet stringent timing requirements by managing resources access and optimizing resource utilization. For instance, in a real-time embedded system, the proxy pattern can be used to manage access to hardware peripherals, ensuring that critical tasks have timely access to required resources. About observer pattern, first of all, the observer pattern is implemented by defining a one-to-many dependency between objects, where the change in one object triggers updates in all its dependents. In a real-time systems, the observer pattern is used to synchronize and coordinate events between objects, ensuring timely communication and responsiveness. And the observer pattern facilitates event-driven communication in real-time systems, allowing components to react to changes promptly and efficiently. Effectiveness of design patterns. Proxy pattern meeting real-time requirements. The proxy pattern effectively meets real-time requirements by providing a surrogate for resource-intensive objects, thereby controlling access and optimizing resource utilization. And by managing resource access, the proxy pattern helps ensure timely execution of critical tasks and meets stringent timing constraints. Also, its effectiveness is on impact on system performance. In real-time systems, the proxy pattern enhances system performance by reducing resources contention and improving resource utilization. By efficiently managing resource access, this pattern helps minimize delays and ensures predictable system behavior. Now about observer pattern, also meeting real-time requirements. The observer pattern effectively meets real-time requirements by facilitating event-driven communication and coordination between objects. By synchronizing event notifications, this pattern ensures timely responses to changes in system state and maintains system responsiveness. Also, impact on system performance. In real-time systems, observer pattern enhances performance by enabling efficient processing and by minimizing event latency and maximizing event responsiveness. The observer pattern helps optimize system throughput and reliability. Now about challenges, resource overhead, synchronization overhead, and complexity. So resource overhead, for example, the use of the proxy pattern for resource management may introduce additional memory overhead, affecting the real-time responsiveness of the system. Now, synchronization overhead. For instance, implementing the observer pattern for event handling may introduce synchronization overhead, potentially leading to delays in event processing. And also for complexity, the interaction between structural design patterns and real-time requirements may increase system complexity, making the system more difficult to understand and maintain. For example, the use of multiple design patterns to meet real-time constraints may lead to complex interactions between components, reducing the overall system predictability. Best practices. Minimize resource overhead by optimizing design pattern implementation to minimize resource overhead and ensure efficient resource utilization. And for optimizing synchronization, we have to implement efficient synchronization mechanisms to minimize synchronization overhead and ensure timely access to shared resources. And also we can simplify design, streamline design patterns to reduce complexity and enhance system maintainability without compromising real-time requirements. And new design patterns or modifications. So for modifications, we can use adaptive scheduler pattern. The adaptive scheduler pattern is designed to dynamically adjust task scheduling and resource allocation in real-time systems. It allows the system to adapt to changing workload conditions and meet real-time requirements efficiently. The pattern involves the use of feedback control mechanisms to monitor system performance and adjust scheduling parameters. And it enables the system to optimize resource usage and meet real-time deadlines under varying workload conditions. Improved responsiveness and predictability in real-time systems, and better utilization of system resources and improved overall system performance. These two are the benefits of this pattern. So that's all for this video. Thank you for watching.